Assalamualaikum warahmatullahi wabarakatuh. My name is Adam Manisat Taufiq. Matrix number 1200529. Today I want to present about topic relations. For the introduction, relationship between elements of set are represented using the structure called a relation, and the relation between a program and its variables, pairs of cities linked by a line flight in a network. For the relations, most direct way to express a relationship between elements of two sets is use or ordered pairs. Set of ordered pairs are called a binary relations. For binary relation R, capital R, we have R A times B, and we use notation A relation B to denote that A B belongs to R, and A R complement B to denote that A B belong to R. For the definition, we use A and B is set, and a binary relation of A to B is subset R of A times B equal to AB. A belong to A, B belong to B. Next, for the example, we use A is set of the students and B is the set of courses. R is the relation that's a pairs of A, B, where A belong to A and B belong to B. So for A, we have Ame, Harith, and Zubair. And the courses B is discrete math, calculus, computer network, and Arabic language. So the question is, if Amir is enrolled only in discrete math, Zubair is enrolled in Arabic and calculus, and Harith is enrolled in discrete math, calculus, and computer network. Which order pair in relation R equal to AB? So the answer is R equal to Amir discrete math, Zubair Arabic, Zubair calculus, Harith discrete math, Harith calculus, and Harith computer network. That's the answer. So for the relation properties, we have learned three properties. That is reflexive, symmetric, and transitive. For reflexivity, relation and element is always relate to itself. So we let R the relation of the set of people consists of pair X, Y, where X and Y have the same mother and the same father. So for the definition, A relation R on a set A called reflexive if A belong to R for every element of A belong to A. So for example, we have the following relations 1, 2, 3, 4. So the R1 is 1 1 R 1 1 1 2 2 1 2 2 3 4 4 1 and 4 4. So R2 we have 1 1 1 2 and 2 1, and R3 we have 1 1 1 2 1 4 2 1 2 2 3 3 3 4 4 1 and 4 4. For R4 we have 2 1 3 1 3 2 4 1 4 2 and 4 3. R5 1 1 1 2 1 3 1 4 2 2 2 3 2 4 3 3 3 4 and 4 4. For R6 we have only 3 4. So the answer is for the R3 and R5 the both of them are reflexive because they have a pair of AA, that is 1 1 2 2 3 3 and 4 4. For the R1, R2, R4 and R6 is not reflexive because that not contain all of these pairs. Example is 3 3 is not in the relation. That is not the reflexive. For next is symmetric. The definition is a relation of R of a set A is called symmetric if B A belong to R whenever A B A B A B A B belong to R for A B belong to R for all A B belong to A. Relation of that is symmetric, and the relation of R on a set A is called antisymmetric. If A equal to B whenever A B belong to R and B A belong to R. For example, is A is 1, 2, 3, 4, and we define a relation R1, R2, R3, and R4. R1 is 1, 1, 1, 3, 2, 4, 3, 1, and 4, 2. For the R2, we have 1, 1, 2, 2, 3, 3, and 4, 4. R3, we have 2, 2, 2, 3, and 3, 4. For the R4, we have 1, 1, 2, 2, 3, 3, and 3, 3, 4, 3, and 4, 4. So the answer is R1 and R2 is symmetric because they have order pair A, B in R1. We have BA in R2. What we have in BA, we have in AB in R1. Also in R2, it's the same symmetric. R3 and R4 is not symmetric because we have for R3 we have 2 3 in belong to R3, but we don't have 3 2 in R3. Same as R4, we have 4 3 in R4, but we don't have 3 4 in the R4. Next, for the transitive, the definition is a relation R on a set A is called transitive whenever A B belong to R and BC belong to R. Then AC belong to R for the ABC belong to A. For example, if A smaller than B and B is smaller than C, then A smaller than C. That is transitive. And if A equal to B and B equal to C, then A equal to C. That's also transitive. Next, for the example of transitive, we use A equal to 1, 2, 3, 4, and we define R1, R2, and R3. R1 we have 1, 1, 1, 2, 1, 3, and 2, 3. And R2 we have 1, 2, 1, 4, 2, 3, and 3, 4. And R3 we have 2, 1, 2, 4, 3, 2, 3, and 3, 4. For the answer is R1 is transitive because 1, 1 and 1, 2 are in R1. Then to be transitive relation, 1, 2 must be there and it's belong to R. Similar for other order pairs. For the R2 is not transitive because 1, 2 and 2, 3 is belong to R2, but 1, 2 is not belong to R2. And the R3 is transitive, same as R1. So for the conclusion, I have 5 points here, and first is a relation of from a set A. It's called to itself is called a relation on A. Next, for the relation R is said to be reflexive if every element is relate to itself. That is, if X R X for every X belong to A. Next is the relation R is said to be symmetric if the relation can go in both directions. That is, if R relation Y implies Y relation X for any X Y belong to A. Finally, a relation is said to be transitive if we can pass along the relation and relate two elements if they are related via a third element. Last is R is transitive if X relation Y and Y relation Z implies that R are relation Z. That's all for me. Thank you.